Okay, so I'm going to go over the steps to make a HAWC Plus proposal and how to create the AORs. So I'll first go over just the steps you'd want to go through, and then I have two examples of creating two different types of AORs with HAWC Plus. So as others have mentioned, the first step in preparing a HAWC Plus proposal would be to first check that whether or not the target you want to observe has been observed before by SOFIA. So go to see the URSA archive where all of the SOFIA data is now held. It may have already been observed, or maybe it was observed by another instrument, which could also be helpful when you are going to create your observations and estimate your observing time. So that's a very useful tool. Also, URSA has some very useful discovery tools available. So please check that out. The next step would be to pick the bands you want to use. HAWC Plus has 5 different bands labeled A, B, C, D, and E, starting from 50 microns, extending all the way out to 214 microns, which I've shown here. And I've also shown the full width half maximum of each beam. And also, please note that band B is still considered shared risk in cycle 9. If you plan on using that, you need to justify why that band is important for your observation. So then the next step would be to decide if you want to observe using total intensity mode or polarization mode for HAWC Plus. So again, HAWC Plus is the polarimeter, has a polarimeter capabilities, but it can also be used purely in total intensity mode. So you choose either total intensity, or if you want to get a polarization map, that's also available in all 5 bands. The next step would be to decide whether or not you are using nod match chop mode on HAWC Plus, or if you're making a larger mapping area on the fly map is also available. So there's 4 different choices between total intensity, polarization mapping, and then which type of nod match chop or on the fly mapping you're using. And I'll go over that a little bit more in the examples. On the fly mapping is recommended for total intensity mode just to reduce overhead, and it also has better sensitivity. It's also offered for polarization mode, but it's also shared risk during cycle 9. So you would need to justify your use of that and make sure if it doesn't work out that you would still get some good science out of that proposal. As part of the on-the-fly mapping, there's 2 different choices for your scan mode. Those are Lissajous and box scan mode. That can be determined in phase 2, so it's not super critical in phase 1. You don't need to actually pick one for phase 1. It can be changed later, but just I'm noting that here. So if you were worried about that, we can visit that later on. One thing to note is also in your choice of the off position in the nod match chop mode, make sure you select an off position that has less than 10% of the source flux. That will help to properly subtract out the background. And also one thing to note is that HAWC Plus does not have a beam rotator. So the position of the array on the sky depends on the airplane heading and the night of the flight. So when you're setting up the AOR, if you're very concerned about this, just note that the positions might change slightly, and the HAWC Plus team will work with you once the observations are planned and it gets closer to making the observations. The next step in the proposal process would be to get a flux estimate for your sources. So as others have mentioned, you'll need to either estimate the source of your object from literature. You can also make an SED model, or another good source of estimate is the archives. So either from previous SOFIA observations or the Herschel archive, which is also I've listed both their own link here and the link through URSA. Will be helpful in estimating far infrared fluxes. And shown here in this plot is the minimum detectable continuum flux in millijanskis for HAWC Plus. versus the wavelength range. So all 5 bands of HAWC Plus, and you see for 3 different modes and for HAWC Plus what the minimum detectable flux would be, and you can see it's somewhere in the hundreds of millijanskis. So this is just to keep in mind when you're determining whether your sources are would be detectable with HAWC Plus or not. So once you have a flux estimate of your object, the next thing to do is to go to our site, or estimate the total integration time on the target. So this is a screenshot of site with the HAWC Plus instrument selected. I would recommend using the default observing conditions in the bottom panel. That should be sufficient for getting a good estimate of the total intensity. And now, how do you cite? I'll go over 2 quick examples. The first one is for point source photometry. So let's assume you are wanting to observe a point source in band D, which is 154 micron, and maybe this is a redshift object. Say it's 110 millijanskis, and you want a signal-to-noise ratio of at least 5. So you would open up site, select HAWC Plus. The drop-down menu here has the different wavebands and polarimeter options. So in this case, we select band D. We are interested in finding how much integration time is needed to achieve a signal-to-noise of 5, so we input that value here. Our astronomical source, we are proposing to observe a point source, so we'd input our estimated intensity. So as I said, 110 millijanskis. And then again, leaving these conditions at their default values. So you would then click calculate, and this is the output screen. So this source, we would estimate roughly 3,300 seconds of total integration time, just under an hour, to get the desired signal-to-noise ratio. So this is very achievable with HAWC Plus on a single leg observation. So then the next step after getting the integration time is we want to build the AOR. So in USpot, one thing to note is that when you're creating an AOR, you only need to make 1 AOR per object per band. So in this example, our total integration time was just under an hour, but it could be several hours depending on what the flux is for your object. So don't worry if it's several hours. That can be broken up later on when we do flight scheduling. But so in this case, we're doing point source photometry. So again, we recommend using on-the-fly mapping. So I guess first, in USpot, you'd go click to create your AOR. As I mentioned, HAWC Plus has 4 different options: total intensity, polarization, and then the on-the-fly mappings for those both of those. So in this case, we would select on-the-fly mapping as we're doing total intensity. The next box that would pop up is this shown here. So the one thing to note for this is that we recommend the on-source time per iteration is, we would say, to select that between 100 and 120 seconds. So that's the box right here, the Lisa scan duration. In this case, in this example, I've set it to 120 seconds. And now to get the total integration time, we would increase the number of iterations until we reach the total desired integration time. So in this case, I would add 28 total iterations of the scans, click apply, and we calculate the total exposure time now is what we desire, 3,360 seconds, to get our desired signal-to-noise ratio of 5. There's some other things you can change, but the main ones that you want to look at are this, is that for on-the-fly mapping, you would set the scan duration and then increase the number of iterations until you get the total integration time that you are looking for.
Ryan,
yes.
This is Aria. Question from Jordan on the chat. What is the maximum covered area using scan mode?
So I think the field of view would depend on the band. but as I think you put in your slides, generally it's several arc minutes, or 1 to 4 arc minutes.
Oh, so I'm asking this question now. So scan mode is within one field of view. You can't cover several fields of view.
Yep. Can I jump in here for a second? Yeah, sorry. So for the scan mode, so if you want to do total intensity, I think that we have done I think one field of view, or a little bit more than one field of view, depending of the band for diffuse emission. If you want to do a scan mode for polarimetry, that's still uncertain because we are still working on it. But using previous observations from the last cycle, we are able to recover at least one field of view, a little bit smaller than one field of view, when we have done 2x2 or 3x3 scan sizes. Yeah, but it's still in progress.
Yeah, so hopefully,
Okay, thank you.
Yeah, hopefully that answers it. But
And Ryan, there's about 10 minutes left.
okay. So that was the first example of just a total intensity type of observation. So now, the next example is a polarization map. So one of the more challenging or difficult parts of creating an AOR for a polarization map is how to estimate the the source percent polarization. So it may not be known beforehand what the polarization is expected to be for the object. I would say to check what the typical polarization is for the type of astronomical object you're observing, and based on the surface brightness of that object. Another good source for information on expected polarization is the Kuiper Airborne Observatory, which may have observed a similar type of object or similar region, or the use of a physical model. But definitely the geos need to provide reference in your proposal and explain the model used and why you're expecting a given source polarization percent. So let's, for an example, in here, you want to observe a star-forming region using band E in HAWC+, and perhaps this area has been observed before with Spire at 250 microns. So luckily, let's say we have an estimated minimum surface brightness of 0.01 Janskis per square arc second. Then we can go into OpenSite. Again, we have the HAWC+ instrument selected. The filter option, in this case, we're doing polarization, so you would select band E plus the HAWC half-wave plate, band E. Again, we want to get a signal-to-noise ratio of at least 5, so we're going to estimate how long it will take to achieve that. And in this example, we're doing an extended source. So again, we have, as I've just assumed, let's say a 5% polarization fraction for this region. And the minimum surface brightness that we're observing is 0.01 Janskis per square arc second. And just make sure you've selected the correct units for your surface brightness. We'd click calculate, and this is the output screen for that calculation. This region would require 1100 seconds of integration time to achieve that signal-to-noise ratio. And one thing to note is that this is the on-source time per detector pixel. So if you plan on binning the data later on, make sure you explicitly explain that in your feasibility section of your proposal. So next step after getting the estimated integration time is to then build the AOR. So opening up USpot, you click Create AOR. And now in this example, we are doing a polarization map, and I will do, in this case, just a chop or a nod match chop mode, which is this button here. And the screen that opens up is shown here. So in creating a nod match chop mode AOR for HAWC+, I keep the time per full nod pattern ABA or ABBA set to 40 seconds. So which is the total integration time on and off for each pointing. So it'd be 20 seconds of on-source time and 20 seconds of off-source time. U-spot's automatically going to include the number of dither positions that you've picked, and as well as the 4 different half-wave plate angles. So for one AOR, that would be it'd be a total of 80 seconds of on-source time for a total intensity AOR, or a total of 320 seconds if you're in polarimetry mode. So in this example, we wanted a total on-source time of 1100 seconds. So we would need to increase the number of AOR repeats until we get to that number. So again, we're in polarimetry mode, so we'd have each AOR is 320 seconds of total on-source time. If we increase that to 4 AOR repeats, click apply, our total exposure time is now 1280 seconds, or 1280 seconds, sorry, which is what we desire to get the correct signal to noise ratio for this region. So just that's maybe one of the more tricky parts. So again, you could change the number of dither patterns, but there's some other options you can change, but that's the main thing I wanted to go over in this example. And then again, select your off position well, and that can be done later on as well. So I think that was the two main examples I wanted to show of nod match chop mode and then on the fly mapping, and the 2 different types of total intensity versus polarization mode that HAWC Plus offers. Are there any other questions about, I know I went over some of these pretty quickly, but perhaps there's other questions.
Hi, Ryan. I just wanted to summarize a question from Jordan, which Enrique already responded. So Jordan was asking whether time data can help with estimating the polarization fraction, and Enrique kindly responded that yes, that's a great way, but note that the wavelength and spatial resolution are really different. At least the spatial resolution is very different. So you need to explain how you go from the Planck to HAWC Plus expectation.
Oh, yeah. Yes.
I don't know if you have anything to add to that.
No, I forgot to mention that Planck could be another good tool for somehow estimating the expected polarization fraction.
Okay, well, I'm not seeing any other questions, and so thank you, Ryan, for that presentation.